Okay, relationship between a numerical and a categorical data. So here we want to display a relationship between a numerical variable and a categorical one. Now remember, numerical deals with numbers, categorical deals with categories. With more than two categories, we use a parallel box plot. Okay, for parallel box plots, we construct individual box plots for each distribution using the same scale. So we will have more than one box plot on the same scale. It could be 2, 3, depending on how many we have. From there, we can determine the relationship by comparing the medians, the interquartile and the range, and the shape. Okay, so we do it for all. Here's an example. Consider the parallel box plot below showing the salary distribution for 4 different age groups, and then we need to write a report. So here we've got ages between 20 and 29, and we have the box plot for that. 30 to 39 years, 40 to 49, and 50 to 65 years old. Now you can see that the box plots are changing. Okay, but let's compare the mediums. Now remember, the mediums are the ones in the middle of each. So if we look at those mediums, we can say from the parallel box plots, we can see that the median salary increases from around, and we won't go back to it, but starts off at about 24,000 for the 20 to 29 year olds to approximately 34,000 for the 50 to 65 year olds. This is typical and shows that salaries are related to age group, because you know, when you start off, you do start off on a lower salary, and over the years it increases. Then if we compare the interquartile range and the range, we should compare both if possible. Now you need to work out the interquartile range. Just remember that the interquartile range, Q3 minus Q1. Okay? Q3 minus Q1. And the range, you should know that's the highest number minus the lowest number. But from the parallel box plots, it can be clearly seen that the spread of salary increases with age. An example is the interquartile range for the 20 to 29 year olds is about 12,000 compared to that of 50 to 65 years old, which is about 20,000. So there is quite a difference there. This indicates that the spread of salaries is related to age. The shape. We've got the parallel box plots. We can see that the shape of the distribution of salaries changes with age. We saw that it changed. 20 to 29 year olds is approximately symmetrical, but becomes more positively skewed as age increases. If we remember the box plots and we look at the box plots again, we've got a big whisker coming to the right, so that means it's positively skewed, and we also know that the median was to the left. We can also see that the age increases, we have outliers appearing, and we saw that the 50 to 65, there was those 3 dots, they were the outliers. And this is showing that some salaries are above the normal and are typical of today's society. Now we know that because have a look at the CEOs in banks. They're a CEO, they're on, $1 million a year. Compared to a normal person, same age, there's no way that they're going to get over $1 million or even close to it. They'll be lucky if they get 80, 90,000, 120, depending on their jobs. But CEO of companies, most of them even earn more than that. So it is related. And then we do have outliers as well. So very normal in society. This indicates that the shape of the distribution of salaries is related to age group. How did he